Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today in the States, well, I say in the States because we write the date different from other countries when we write the month before the day. So today, basically, November 23rd will be written 1123. And if you are a number lover like myself, you would recognize the first four numbers as the first four entries of Da Vinci, or I'm sorry, I was going to say Da Vinci. I lost my mind. Fibonacci sequence, right? I wanted to say after that is if you had watched the movie or read the book of Dan Brown's Da Vinci Code, you would have heard this term before. Um, and Fibonacci's sequence really is a very interesting one. And you will see that, well, it has a lot of things inside of it, but I'm going to mention only one today. And basically, Fibonacci sequence starts. So you can think of it as you have an organism. Okay, here it is, just a single baby, say bacteria or something. And it takes 1 unit or 1 day to become an adult. When it becomes an adult, I'm going to use it with a dot in the middle so you know that this is a baby that's an adult. So it starts with a baby. The following day it becomes adult. Once it's adult, it begets a baby every single day. So this is day one. So if I write the days, this is day one, this is day two. And then in day three, here is the original organism, and then it begets a baby. So that's day three. On day four, here is the original one. The baby becomes an adult, and the first adult gets a new baby. So you see, one, one, they become two, then become three. One, one, two, three. And then the following day, if you want to continue, these two adults are here. The baby becomes an adult, and the original two adults beget two babies, and you get five. And you get the sequence. So this sequence really starts with 1, 1, and then every day thereafter, the number here is the sum of the previous two. Why? Because they became adults, right? So 1 and 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 8, 13, 21, 34, 55, 89, and so on and so forth, 134. And it keeps going like that till infinity. So, and you say, okay, so what? There is, just search Fibonacci and you will see a lot of, interesting things in biology, in even architecture of old, like Romans and stuff like that. It's invades everything. But one interesting that I wanted to talk to you about, if you have heard the term a golden ratio. What's a golden ratio? So the golden ratio is basically a number that if you take its reciprocal, the difference between them is 1. You say, wait, what is that? Yeah. If you try to pick, for example, 2 and 1/2, 2 and 1/2, the difference between them is 1.5. It's not 1. If you take 10 and 1/10, the difference is 9.9. But there is only a unique number called the golden ratio, that if you take its reciprocal, the difference between the number and its reciprocal is 1. And this number, by the way, is to 3 decimal places is 1.618. It's called the golden ratio. And as I said, you will see it everywhere in nature. So look at 1.618. Oops, I'm sorry. If you take its reciprocal, x to the negative 1, you get 0.618. And if you take, of course, the reciprocal of that, you get this one back. So, and you say, okay, so what does that have to do with Fibonacci? Well, if you divide every two like consecutive numbers, 1 divided by 1 is 1, and 2 divided by 1 is 2. These are the limits of these ratios, and they will get closer to the 1, then closer to the 2, then closer to the 1, and then in the limit, they would become 1.618. Isn't that nice? So for example, you divide 3 by 2, you get 1.5 midway. You divide 5 by 3, you get 1.6667, right? Yeah, you love 6, 7, I know. Then you divide 8 by 5, you get 1.6. You see, after we reach the point 8, we are at 1 point, something between 1.6 and 1.67. Then you divide 21, but let's do it with a calculator so I don't have a space here. So if I say 21 over 13, it's 1.615. Then if you divide 34 by 21, you get 1.619. We are only 1,000th away from the golden ratio. And you can see that that's basically, that's something interesting about Fibonacci. I just, try to celebrate this great mathematician by mentioning that since today refers to the first 4 entries of his sequence, so we talk a little bit about him. I would advise you to go online and search Fibonacci in nature, and you will be amazed. Thanks for your time. It's a very short one, and I hope to see you soon.